Morning, everybody. Just searching for the file brainstorming question mixed answer copy probably. Please ask your doubt, and if you have any, otherwise we have. I will start with my agenda. If you have any doubts, please ask. Few students have asked a few doubts. In fact, outside the class on the group. So I'll show you. The doubts are this. Likewise, you can send me WhatsApp messages, and I can take up the doubts. Like these three questions have been asked. Four questions: a solution of 0.1 mcl negative and 10 to the power minus 4 mcro42 negative. If solid AgNO3 is gradually added to this solution, what will be the concentration of this? Similarly, 500 ml of 0.4 m AgNO3 is mixed with 500 ml of 2 m NH3. So this comes in the part of a solubility equilibrium, and in solubility it is selective precipitation, as well as some complexation equilibrium problem, some thought-based problems. And last one is H3A is a weak triprotic acid. What is the value of px of 0.1 m H3A solution? So that is an ordinary problem. Simply a tribasic acid problem. So these are the questions asked. If any other questions are there, please ask me so that I have the agenda set. Few other questions I have taken, which I will give you in the next session, preparing the file for it. So let us last class questions quickly. I will ask you that how many of you have done this brainstorming mixed questions. And last class somebody asked about the inversion temperature. I'll give you the theory of this. So please tell me quickly. Question number 3, you tried, you got the answer, everyone?
Yes,
Question Mil gaya answer? Okay. So this is one kind of a question which is a very unique question. Anytime ITJ can ask, and if you can do this problem, I'm very sure you can do the ordinary problems, because this is the problem where volume is a variable. So then in this way we are also practicing it. The questions are also practiced. So all the kinetics fundas are there, and we get it clear. So the question number 4 is almost like this. If you have done this, only thing you will realize that how I have created these problems that you get the answer perfectly. Question number 4, have you also done? Anyone? Not done, then please do it. If you can do it, then you will enjoy the problem. Similarly, question number 5 is also based on exactly the similar concept. Okay, carried out. Anyone want discuss me these questions, or you can do on your own? Should I move ahead? All these 3 questions are a single type of questions. I am moving ahead. Question number 6, have you got the answer? I have briefly explained. Have you got the answer? Okay, this is a cube. And I have taken some time to create this cube because now I'm going to duplicate many cubes out of it. And we'll talk about them so that you can understand the configuration of this. Let's save it. So this cube, if you start cutting it, you will start cutting from the corner. It looks like this. If you start cutting the corners, truncation. Why I'm discussing this? Because then you will get a symmetry, and from that symmetry you will realize the importance of the problem. And let us duplicate another one very quickly, then we can get it. The answer will be very short, but I have to explain this. That is why I'm preparing this. Now, if you start doing it similar manner, a situation will come when you will realize that half of this you pick and make it like this. Something like this will be seen at one stage of cutting. Like this. अभी मैं जल्दी बना रहा हूँ. Thanks to the technology, I can explain you this quickly. And that too, I am doing बहुत जल्दी जल्दी इसलिए थोड़ा सा गलत भी हो रहा है. Otherwise, I can show you like now you will get to this stage and you see what kind of solid is this, and you can see this stage. I think it is consuming a lot of time. Let me see if I have these figures. I can show you simply. Yeah, I have these figures somewhere stored, so I can show you. So if you cut a cube, you can see you will get to this situation, and this will be the solid which is formed. And if you keep on continuing, cutting it, so this will go from this stage to this stage, and ultimately you will get to this stage. Can you see this? So in a cube, you will get a octahedron of this kind. So when you start cutting the octahedron, now we started cutting the octahedron. I think I must have, yeah, another figure here. If you start cutting the octahedron, see what is going to happen. Truncated octahedron. First, it will make a not a hexagon. See, one of the faces will be one of the face must have drawn somewhere more clearly. Yeah. See, one of the diagram is showing it. Could you understand this? Please give affirmative. You understand this diagram?
Yes, sir.
So this is how you see when you make a tetrahedron, when you start cutting an octahedron, okay, a stage will come. Like if I talk about, like see the question of the solution of this question is written here. Incidentally, I got it. Okay. So you get this. Now you create a cube, and the edge length of cube is 0, 0, 0, 0, A0, and the corners are 0, A by 2, A by 2. So what is the coordinates of this center of this triangle? Can you get this? Because you know the coordinate of this point, you know the coordinate of this point, you know the coordinate of this point. Do you understand? So quickly get the coordinate of this, and this is coming out to be A by 3, A by 3 to A by 3, and get the coordinate of this. This is A by 2, A and A by 2. Get the distance between these two, and you get the edge length of the cube. And then try the problem. Understood?
How truncating it led to the formation of maximum edge length, sir?
Maximum edge length means what? Otherwise, you could not put any cube into this one. No? Cube of maximum edge length, only you can put this one. No? All other cubes which you can inscribe inside it will come out of this, and otherwise they will be dropping. If the length is less than this, then they will be inside this octahedron. At this point, you start looking at initial cutting, how the triangle looks like. Initially, when you start cutting, it will look like this. First cut is like this. Okay. I am talking only about the one face. Then afterwards, the cut proceeded like this. Okay. So what kind of shape you can see here? First, it was not even a hexagon. It was like something like this. First this, then small one, then this, then small one, then this. That was the shape. Then it comes into what? Something like a perfect regular hexagon. After this stage, if you start cutting it, it will get a shape of, after that, it will take a shape of this inverted triangle. After this cutting, you will get to the stage where you will get a inverted triangle. And when you start cutting it, if you cutting continued like this, then what you are going to happen? Then see, I'm using another pen to cut it. Suppose blue pen. Cutting it like this, cutting it like this, and cutting it like this. So this is triangle will start getting what? Smaller. If you continue with this cutting, it will still become smaller, and it will still become smaller. And ultimately this triangle, which is getting smaller, 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 will become a point. So at one point, it will become a point. That is the maximum point. And this is the point where you will get a cube. Is that clear?
Yes, sir.
Yeah, that's a very interesting shape. It's called platonic solids. So that is why they have asked sometimes back in ITJ. Amazing thing is the symmetry of all these things are, related. Like when you cut icosahedron, you get what? I can show you. I have figures. So these figures are all related figures. So that is why they keep on asking it in. See, this icosahedron is there. And if you start cutting it, you're going to get this dodecahedron. Okay. Similarly, this truncation is a very important process shown you in there. You start cutting it, ultimately, you are going to get a dodecahedron. And these are the related things. Cubooctahedron, if you start cutting a cube, and then you get to this one. Like this, when you start cutting an octahedron, these are some stages of cutting. I think there is no clear-cut diagram. So leave it now. You understand, I hope. So I hope you understand. Should I
Yes.
move ahead? Yeah. So it's very difficult to immediately create it. In classrooms, we used to teach and then tell. So it is interesting question if you do it. In online classes, it's very difficult to tell.
Sir, I'm getting the answer as 27.
27?
Yes, sir.
I think I have tested the answer. Solution part. We have to solve it then, na? 27 is not the answer. Whatever answer I have given is perfect answer. So what is the problem? Edge length of the octahedral, you see 3 by, that is why I said this question. Edge length of the octahedral is 3 by root 2. What volume of cube of maximum edge length which can be inscribed inside the octahedral? So if the octahedron is of this length, start creating an octahedron here. I have shown you the scheme, na? Make a cube first. Coordinates of the cube. The easiest way is to get the coordinates of the cube first. To put your cube on the center of Cartesian axis. So this point is 0, 0, 0. This point is what? Let us suppose that this is x-axis, this is y-axis, this is z-axis. So this point is equals to what? It is 0, a 0. This point is what? This is a 0, 0. And this point is what? 0, 0, a. You proceed like this. And this point is what? This is a 0, a. All right. Am I clear? Let us check. Suppose this is x-axis. Suppose this is y-axis. Suppose this is z-axis. So 0, 0, 0, all right. This is a 0, 0, all right. This is 0, A0, all right. All right. Okay. Now you have 1 and 1. These are the 2 points of a octahedral. So what is the coordinate of this and what is the coordinate of this? Tell me what is the coordinate of this, then we can get it. Coordinate of this will be what? A by 2, A by 2, sorry, A by 2, 0, A by 2. And coordinate of this will be what? 0. Coordinate of this will be what? 0, A by 2 and A by 2. Do you agree? So quickly
Yes,
get
sir.
distance between them. And this distance is equals to root 3 upon root 2a. Get the distance. This distance is equals to what? A by 2 whole square plus A by 2 whole square plus under root of this. All right. So under root of this is equals to root 3a. So solve it. 3 root 2 is equals to a square by 4 plus a square by 4. 2a square by 4 under root of this is equals to root 2a by 2. So of course this root 2 is cancelled. So a is equals to 6 Armstrong. So edge length of this is equals to 6 Armstrong. You got it? Now you have to get the point, because this is going to be like this. This is one, the edge length, and other vertices will be like this. So get this point, and this point will be a by 2 and a by 2 and a. So you have 3 coordinates now, 1, 2, and 3. Get the point. Okay, get the point of the centroid, and similarly you can get the point of this centroid. Get this. Okay, so one more point is there, you can easily do it. Then you do it and find out and tell me what is the answer. Anyone who has got the answer to confirm, because I am very sure I can show you the solution somewhere, but it will take some time. We have to discuss what other problems as well. So please try it and give confirmation if you have get the answer. Okay, should I move ahead?
Yes, sir.
I have a lot of files and I must have missed it sometime, someplace the solutions I missed it. Otherwise, I could have shown you the solution. Okay, I'll check and send the solution on the group. No problem. So that next question is, how much water should be added to 1 liter of 1 m solution of A plus B negative to make us pH equal to 6? Have you done this problem? Question number 8. Anyone? Or any doubts?
Yes, sir.
Yeah, who has done it? Please uncam and tell me. Ved Prakash, have you done it? Have you got the answer?
Yes, sir.
Okay, if you got the answer, you must have enjoyed it. So this is a problem where, what was your approach of getting the answer? I would like to know. क्या किया आपने? Because my approach could be different, your approach could be different. Let us see how you have done it.
Using those both two equations of K and taking H plus as 10 power 6, 10 power minus 6.
Okay, so you are telling me that you have done something like this: A negative plus B positive plus H2O you wrote, that is forming HA plus BUH using this equation, and using the equilibrium constant of this, which is equal to Kw upon K into Kb, which is called hydrolysis KH. Have you done it like this?
No, so separately I took both equilibriums, not together.
Okay, you have taken A negative plus H2O is changing into AH plus OH negative, and B positive plus H2O changing into BOH plus H plus. And we can see that K of HA is given as 5. So this is Kw upon 10 to the power minus 5, which is coming out to be 10 to the power minus 9. And B plus, this is 9, that is Kw upon 10 to the power minus 9, which is 10 to the power minus 5. Quite different they are. All right. So how much water should be added in 1 m solution? That means suppose the concentration of this is 1 and you have added V liters of water. You have done it probably like this. 1 by
Yes.
V. Similarly, this is also 1 and you have done it 1 by V. Something like this. Okay. So from here it is minus X and here it is X and here it is X. So this is minus Y and this is Y and this is Y. Have you proceeded like this? Very good.
Yes. Yes, sir.
Then 1 by V minus X and X and this X minus Y is reacting. How to proceed further? Tell
One
me.
more equilibrium of H plus and OH minus with
Okay,
water.
fantastic. H plus plus OH minus. Chaining into H2O. Very good. Now you have done what? You have developed this method on your own. Somebody taught you this method.
I mean, on theory, what
Theory?
teacher taught. Theory of acid.
Very good, very good. Whoever taught you, that is full marks to this. That is a very good approach of attacking it, the problem. So here you will write X and Y. Very good. Now what do you have to do? How to proceed? So
We'll do
I-
charge balance.
charge balance. So you can
I
also
got
do one more equation. What is that?
I'm not able to remember one. I'll
Okay,
check my
good.
solution.
Done. Good, good, good. That's it. I understood that how you have done it. That is sufficient. So see, which equilibrium constant is bigger? You see this equilibrium constant is smaller. This equilibrium constant is bigger. As soon as you see this equilibrium constant is bigger, you know that this H plus is going to be more than OH negative. If H plus is going to be more than OH negative, then H plus is going to consume the OH negative, because the third equilibrium is totally into the forward direction, because this is 10 to the power 14. This equilibrium will completely shift into the forward direction. So here what we need to do, that Y will consume X and I will write here Y minus X. So this will become X minus X. So this will become Y minus X and यहाँ पे मैंने कुछ गलती लिख दी है. So here I will write Y minus X and here I will write X minus X. Now guide me what I should do. One thing is sure, X minus X could not be 0. X minus X could not be 0. But so this is the concept. If there is no OH negative, then there are only those OH negatives are left which are coming from the water. So in this case, we should write it here what? A. A is the OH negative which is coming from the water. And you very well know, if A is the OH negative which is coming from water, this much of H plus also must come from the water. So add here A. So this is the thought process. This is the thought process. So this is a case of equilibrium. If you have done it, so you have got to this point. And here only this thing you have to do in a fraction of second. We are doing in the basic manner. There are other shortcut methods as well, but this is for understanding of the problem. So we are here and it has been given that pH of the solution is 6, which means that what has been given, Y minus X plus A is given 10 to the power minus 6. If that is given, which means that A is also given. A is the H plus which is coming from water or the OH negative, so that is equal to 10 to the power minus 8. Tell me, is you understood this process? That is the idea. Y minus X plus A is 10 to the power minus 6 and A is equals to 10 to the power minus 8. So what happens, that Y minus X becomes what? Y minus X becomes the exact value of Y minus X becomes 10 to the power minus 6 minus 10 to the power minus 8. This is one condition we got here. This is the one condition we got here. Okay. And I think this condition is more than sufficient to solve the problem, because now you take any equilibrium. Let us take the equilibrium of HA. So HA is breaking into A negative plus H plus. So the equilibrium constant of HA was equal to what? Equilibrium constant of HA was A negative 10 to the power minus 5. So 10 to the power minus 5 must be equal to A negative, and A negative you get from here. How much is this? 1 by capital V minus X. And H plus is equals to 10 to the power minus 6 already given, and divided by HA, and you see HA is equals to how much? HA is equals to X. So you see from there you can get the value of X and V you can easily solve, because Y minus X you already know. Y minus X, the value of Y minus X you already know. We can solve this problem like this. Ved Prakash, have you done it like this? Or something else?
I written those two equilibrium equations and multiplied them, which will eliminate H plus and OH minus, and I'll get a condition between X and Y.
You already got the condition. Y minus X is equals to, already you can see. Y
I
can,
got a different condition.
okay.
I got X plus Y equals to 1 by V.
X plus Y is equals to 1 by V simply. Okay,
Yes, sir.
done. So this is also perfect, and that is also perfect. And you see in this question, how to get this X and Y value, next X and Y value. So see, you can write also in one equation, realize one thing also, that total A negative concentration plus total OH negative concentration is equal to total B positive concentration plus total H plus concentration. And we already seen that H plus concentration is 10 to the power minus 6. And we already saw that this is 10 to the power minus 8. And we already saw that this B positive will be equal to, from this equation we can see 1 by V minus Y. And this A negative is equals to 1 by V minus X. So we can also use this expression to get the answer.
This and the above one are same equations.
Basically, they are the same equation. What we got here, y minus x is equals to this. So once we get the y in terms of x, how can we proceed now? Once we get the y is equals to x, how can we proceed now? Can you give idea? You tell me how you solved, then I tell you.
Yes, sir. I first two equations are multiplied, sir. KW by K and KW by KV, those two equations.
First two equations you multiplied. Then that
Yes, sir.
becomes what? A negative plus B positive. And plus H2 as well, no?
Yes.
HA plus B which? That's you're telling me?
Yes, sir. No, H and BOH are X and Y. And this K equilibrium is 1.
So of course, K equilibrium is 1 because K into KB.
So A is 1 minus V 1 by V minus X, B is 1 by V minus Y, and H and HB are X comma Y.
X and Y. Okay. So from this,
Yes, sir. Now I equate these two products.
X,
Now as K equilibrium is 1, product of left hand side 2 terms and right hand side 2 terms is equal.
done. Okay. I'll try to see what is the method. But I think very simple method is we have to, here answer is because A is given, Y minus X is already known, Y is known in terms of X, and X is known in terms of Y. So we can also do, I don't want to use Brahmastra here, very simple method of getting the answer. Otherwise,
Sir, we can write equations of Ka and Kb and divide them.
K is equals to A negative into H plus divided by HA, and Kb is equals to B positive into OH negative divided by BOH. It's telling this, and we are dividing this.
Yes.
So from this we get K by Kb is equal to A negative to H plus. So what are we going to get? HA into BOH divided by B plus into H negative. So from this, what you are going to get?
So already we know the values of A minus H plus H.
We know A minus, we know B plus. I think I've done it a very, very easy manner. I don't want to give such a difficult problem at this stage. So I'll simply do it by that method. But I want that basic method, and something I slipped, and that comes out to be such a simple question. But to be very frank, now I am stuck because I'm frankly speaking, I'm stuck, and then I have to use that Khatarnak method I don't want to use. Just give me one solution was there. Sometimes you fell in your old trap, you know. कभी-कभी आप अपने ही जाल में फंस जाते हो. So the same situation is here. So I've got stuck into this one. Anyway, if you stuck there, then I will simply solve it like this. The solution is not a problem. Solution is not a problem. Way to get the solution is the problem, okay? Way to get the solution is a problem. You know, one thing is sure, that this A negative will always be equal to what, you know, C times of K divided by K plus H plus. That you can get from the mass balance. How can? Because this total A negative plus total HA in the solution will definitely be equal to what? 1 by V. There is no doubt about that. There is no doubt about that. And this A negative and plus HA can be written as what? HA can be written as A negative into H plus upon K. I don't want to tell you this method, but then I have to stuck because I'm not getting. Anyway, so that is A negative 1 plus H plus upon K is equals to 1 by V. So you can simply put A negative is equals to what? A negative is equals to 1 by V multiplied by Ka divided by K plus H plus. Okay. Very similar manner, you can show that the B positive will be equal to 1 by V into this time, this is Kb into Kb plus OH negative. Simply put into this equation that B positive is equals to, B positive was 1 by V into Kb divided by Kb plus OH negative, and plus this is B positive plus H positive, which you already know, is equals to A negative, which is 1 by V into K divided by K plus H plus and plus OH negative. So, you know, all the unknowns are now eliminated. We can get it simply, you know, 1 by V and Kb upon Kb plus OH negative minus K upon K plus OH negative. Okay, but I don't like this method because this is, you know, OH negative minus H positive. And you already know the value. So only unknown is V, and you will quickly get the answer. But this is cheating, you know. I don't like this method. I like that basic one, and I'm not right now, which I always used to tell students, you can do it. This is another method, okay? Your method I could not understand. Please share in the WhatsApp. The problem is given to show you. So what are the variations of this problem, you know? In this case, you see the hydrolysis constant, degree of hydrolysis of both has varied. Another question I would have asked that is that this stage, what is the ratio of degree of dissociation of the acid and base? So that is another very, very valid thing and very interesting thing is So all this host of answers you can give from this problem, and you're totally under the control. So we come to know that hydrolysis of salt of a weak acid and weak base when we solve the problem and all this. But I frankly don't want the hi-fi method. Simple method is needed. So I'm very sorry. It is not striking me, and I'm desperately trying how I used to solve it in the class. Because in class, I don't tell all these things by a very simple approach. So if any one of you have that very simple approach, you do it. Okay. And this is the theory of it. In this manner, we can tackle the problem. I give you one simple thing. If pH is given, that problem is totally solvable. If in any problem pH is given, howsoever horrible it looks like, but it is going to be absolutely solved in fraction of second. You can approach it, this problem like this. Do you understand this method, what I have done? Okay. Understand, Ved Prakash? समझ आ गया?
Yes, sir.
Everyone, जो भी देख रहे हैं समझ में आ गया? I'm very sorry I got stuck over there. I don't want to use this, this method, but nevertheless, if anyone has a simple answer, you can tell me, or just give me the solution. And total research on this problem is needed. So that will give you full satisfaction that at this stage, what is the hydrolysis of this? That means what is the ratio of x by y when you can get this. Normally, when you solve the problem, you take what x is equals to y. Here in first time, you will find that x and y are not something like comparable. One will be few times of other. So that is the situation. And you see, I have given a pH of solution 6. If I take it 6.7, problem will become even more interesting. Another thing is you will find that so much water you need to add here. So much water you need to add here to simply take it from, to pH 6, which gives you the idea that this is really a buffer solution. Because pH is constant, you are adding water into it, pH is not changing. You are adding acid into it, pH is not changing. You're adding base into it, pH is not changing. So that is why I created this problem to give you a clear answer that this is also a kind of a buffer solution. I hope you got the answers and understand. But still, I'm desperate. I don't want to run away from a problem. How I used to solve it like this, I don't understand.
Sir, I got x by y as 0.1.
Yeah, 0.1. That's an interesting thing now. 0.1 means what? X by y is 0.1. That means 1 by 10. That means y is 10 times of x. That is what is happening. Normally, when you solve the problem, what you say? X is equals to y. But here, x and y are so different. So it is a conceptual problem. That degree of hydrolysis of salt of weak acid and weak base is valid only in a very high concentration situation. When you start decreasing the concentration, then that funda is not valid. But you see the answer. Kind of water you have to add here is 10 to the power 6 liters. So that means when the formula will break, you will have to add huge amount of water. That is why this problem has been created, to give you the intuition of the problem. Understood? I'm really sorry why I'm not getting that. Last time Shishir has also solved this problem without any assistance, and he has his own method. So very good. But then this method is, it's like machine factory. You put in this and you get the answer. That is not giving you the feel of the thing. That is the only problem. Let's move ahead.
Sir, in the beginning, how did you write plus a? Sir?
In the beginning, what I write?
Y minus x plus a, you wrote plus a.
Yeah.
For h minus and o minus.
This is the most creative approach, beta. This is the most creative approach. I always take the problem like in this manner. In this manner, I used to say that when you solve the equilibrium problem, you have this thing in your mind, what is happening. This thing in your mind, what is happening. See, and that is why I wrote this. There is a species A negative. There must be species HA. There is a species B negative. There was a species BH. There is H plus and there is OH negative. Do you agree? Suppose initially you have added something into this one. You've added here 1. Suppose you added here 1. Okay. And you have added here 1 as well. And that time water was neutral 10 to the power minus 7, 10 to the power minus 7. Do you agree something like this will happen? Yeah, okay. So afterwards, this equilibrium will definitely shift in forward direction. It will go in minus x plus x. And as soon as A negative will become HA, this will create one OH negative. So here you will add x. Do you agree? When A negative will change into HA, X will be added in OH negative. Do you agree?
Yes, sir.
So similarly, B positive will be minus Y, then this will be plus Y, and here something Y will be added, of course. Now in
Yes.
that situation, the water's equilibrium is disturbed, and water equilibrium is disturbed, and it will go either in forward direction or backward direction, depending on the situation. No, it will definitely go in the backward direction, because either OH negative is more than, ionic product of H plus and OH negative is more than 10 to the power minus 7 right now. Okay, so what is going to happen? Something like this, that we know always strong acid and strong bases are reacted. So suppose Y is greater than X. So what I am going to do? Y is greater than X, then I'm writing minus X and minus X here. Because strong acid should always be, neutralized outside the acid solution. So is this equilibrium still attained? No, it is not still attained, because still we can see that OH negative is equals to what? 10 to the power minus 7. And this is what? If you are taking, this is what? 10 to the power minus 7 plus Y minus X. This time KW is not satisfied. So definitely this equilibrium will shift in which direction? Backward direction. And suppose it is going minus Z and minus Z. Now I will write final configuration. 1 minus X, this is X, 1 minus Y, this is Y, and I will take very smartly 10 to the power minus 7 minus Z is equals to A. So this will become what? Y minus X plus A. Do you agree?
Yes, sir.
Right now, we have not taken any approximation. This thing I write so that student understand it very perfectly. So I always try to write it in such manner, because this grid students don't like. So I show this here like this: A negative plus H2O changing into A plus AH plus OH negative, B positive plus H2O changing into BOH plus H plus, and H plus plus OH negative changing into H2O. See right here, suppose it is C minus X, then X, and then X. Suppose this is C minus Y, this is Y, this is Y. So you get Y, OH negative is X and Y. And suppose the equilibrium constants are also given, you get an idea that X is greater than Y. Either X will be greater than Y or Y will be greater than X. If X is greater than Y, what you are going to do? X minus Y, and Y minus Y, Y minus Y. Perfectly understood. But at this point, your answer is that H plus is 0. Is it possible? No. So when a solution is acidic, definitely someone is giving H plus ion, but nobody is giving OH negative ion. So OH negative is coming from where? Water. Here, the solution is basic. If the solution is basic, someone has given OH negative ion. Okay, someone has given OH negative ion. That is why a solution is basic. So what about the acid? From where the H plus ion will come? Definitely they will come from water. And when they will come from water, the same amount of OH negative will also come from water. So here at this point, I will add A. I will also add here A. And now this is the situation. Now, if you don't agree with me, you check this condition by charge balance. Writing charge balance. You'll write A negative plus OH negative just to verify it is B positive plus H positive. So what is A negative? C minus X. What is B positive? C minus Y. What is OH negative here? OH negative here is equals to X minus Y. And what is H plus here? H plus here is equals to, X minus Y plus A. And H plus here is equals to simply A. See, is this satisfied or not? Of course, it is satisfied. So in this way, this is just a confirmatory test. So I want the student to be solving problem like this, because otherwise they will become machine. There is no problem. Every problem they'll try to do. But in ionic equilibrium is game of intuition. So most of the time you have to use your intuition. So I don't want you to machine. Is that understand, Charan? Clear?
Yes, sir.
Yeah. So that is the most basic step through which we understand this. I'm still very sorry, because otherwise I would not have given this problem if it is not solved like this. But what is happening, I don't know. Sometimes you got stuck, everyone, but otherwise the answer is there. I'm not very happy with the answers. I'm happy with the way the answers are given. This was a very, very easy question. I don't think there is nothing in this question. Should I discuss it? Have we done it? These are some routine questions. What is the funda of this problem? Funda of this problem is the stoichiometric coefficients are different. 2a plus 3b changing into c. And you see, experiment started with 2 and 6. So perfectly all right. If this is 2 and this is 6, they are stoichiometric ratios. And if they're in stoichiometric ratio, the problem is not going to give you some problem. If they're not in stoichiometric ratios, then it is going to be a big, big problem. Okay, because there you will set up the rate equation like this: 1 by 2 dA by dt is equals to k times of A into B. Immediately we'll stick to this point that this is 2 and 6. So this is, you will write here 2 minus 2x, and this will be 6 minus 3x. So if you just write it here, 2 minus 2x, then minus 1 by 2 d 2 minus 2x upon dt. And I think that we are wasting time here. You can easily do it. This term will become what? Dx by dt is equals to k times of, you can take a factor out of it, 2, 1 minus x, and you can take a factor out of here, 3 into 1 minus x. So that become a very simple equation. Factor of 2k and 2 into 3, that means 6k will be here, and that is 1 minus x whole square, that is dx by dt. So you get the value of x, and in this way you will proceed to solve the problem and find the half-life time of this seconds in the given condition. Only in this condition you get the half-life. Why? Because if these two are not non-stoichiometric ratios, you could not get the half-life. In that situation, half-life can only be got if one is present in huge excess. Like if this is present 600, 6000, and this is 2, then reaction will be simply following which order? Order with respect to A. That will become a first order reaction. Then you can say the half-life is when the 2 will become 1. So the idea of the problem is this.
So this is not stoichiometric, 2 and 6.
This is not stoichiometric coefficient.
Yes. 2, 6 is, that is 2:3.
2 and 6. Oh my God. Yeah. Find the half-life time of A in the seconds given below. Okay, this is not, I realized. Yes, you're right. So how we will find out the half time then?
I mean, 1 minus x and 1 minus 2x. We'll integrate those two, we'll get answer. X
Yeah.
as 1 by 2.
Okay, half-life time of A is given, no? So in this respect, it has been given. Yes, you're right. Thank you for telling. Bacho, I just forgot that I could not, 2m and 6m. गड़बड़ हो गया ये तो. So this is 1 minus x and 1 minus 2x is perfectly all right. Because this is not stoichiometric ratio. I thought that this question must be easy. Okay. So this is not stoichiometric ratio. That is why it is 1 minus x, and this is, you will take
2 minus x.
Sir, 2 minus x, no, sir.
Yeah, 1 minus x and 2 minus x. See, these silly mistakes you have not to do. I have done these silly mistakes today. I have not taken my sleep today, it seems. Anyway, this is 2 minus 2x This is 6 minus 3x. So k is equals to dx by dt is equals to k times of 2 minus 2x and 6 minus 3x. So I can take common here 2k, and from there I'm getting, take 3 out, 3. So this is 1 minus x, and if you take 3 out, then 2 minus x. All right. So basically you have to solve dx by dt, dx and 1 minus x and 2 minus x is equals to 6 times of k dt. The fund of the problem was this. Thank you. That question is done. That question is done. 10 mole of liquid A, 20 moles of liquid B is taken in a cylinder. Have you done it?
Yes, sir.
Any quadratic equation was formed? Probably there is a quadratic equation which has to be formed.
Yes, sir.
Anyone want to discuss this problem? Funda of this problem. Every problem I have selected here is a theoretical problem. Every problem I have selected here is a theoretical problem. Kind of a trick. Some tricks are there, or some, theoretical points are associated with this one. This is related to ideal solution, and ideal solution can be totally separated by fractional distillation. Totally separated. 100% separated if it is ideal. No solution is ideal, but if it is an ideal solution, it can be 100% separated. So this question is giving you the idea of that thing. But if it is a real solution, you could not separate them 100%. Some of the solution will be definitely wasted as a mixture. This is the greater idea of the liquid solution, this part, which is called binary solution part. Okay. So if you have any doubt, you ask me, I'll give you the whole account of this one. This, is a phase diagram. This is a phase diagram. What is the meaning of phase diagram? If this is pressure versus composition graph, at very high pressure, there's a liquid. At very low pressure, there is a gas. But this portion belongs to what? Liquid and vapor equilibrium. That means in this portion, there will be liquid vapor equilibrium. So the question belongs to this category. So if you start from there, I already told you in the last class that you start from a very high pressure. You've taken a piston, and on this piston, you have applied a lot of pressure. If you have applied a lot of pressure, so there will be only liquid. But when you gradually start decreasing the pressure, at one point, what will happen? A first drop of vapor will form at one point. And the first drop of vapor will form will correspond to this point. And if you still continue to decrease the pressure, then there will be liquid vapor equilibrium. There will be liquid vapor equilibrium, liquid vapor as well. And this is a very interesting thing, because the more volatile component will be more in the vapor phase and less in the liquid phase. So that will go a series of change. And finally, if you keep on decreasing the pressure, at one point, it will be totally gasified. So this is the last point where it is totally gasified. And there is a very interesting rule that if you just cut it by horizontal lines, there is a series of composition. So the first composition like this, that will be the liquids composition, that will be the vapor composition. The second stage will be like this. Then third stage will be like this. So clearly the vapor composition is going towards this, and liquid composition is also going towards this. So at certain point, there will be limiting value. That the whole problem is based on this. They ask you, and we have asked this question not on the first and last drop, in the middle, what will happen? That is the idea of the problem. So anytime it can be asked in JEE, they have not asked it. They've always asked first drop and last drop, first drop and last drop, but they've never asked the in between what will happen. So this is the idea. How this is very important? This is very important because this is related to another phase diagram, which you make a temperature versus composition graph. When you make a temperature versus composition graph, this graph becomes what, inverted. If that was initially P naught A. This is suppose XA is equals to 1. So XA is equals to 1. More volatile component will have less boiling point. So that will be the boiling point of what? A. And that will be the boiling point of pure B. And this time, this line will not be a straight line. This line will not be a straight line. In fact, this line will go like this. If you ask me, sir, why it is curve, why it is a hyperbolic curve, it will not be a straight line. It is very difficult to prove because temperature is changing. If temperature is changing, then vapor pressure of A and B is changing at every stage. So that will be an exponential function. So it is difficult to prove, but not very difficult. So it will gradually increase. Okay. And if it is so this time low temperature means what? Liquid. This is the phase diagram. And high temperature will what? Vapor. So this line represents what? Vapor composition. This line represents what? Liquids composition. So JEE can go up to this level. Now this is a perfectly distillation graph. Why it is distillation graph? Because if this is the liquids composition, this composition vapor will come out. So the funda of this is used in fractional distillation. So the vapors you can simply take like this. You can think like this, that there is a vessel and there is connected to another vessel. This is connected to another vessel and you are heating it. And every vessel is containing a thermometer. And the first vessel, okay, when you start heating in the first vessel, the thermometer reading in the first vessel will be least. And thermometer reading in the last vessel will be the most. Why? Because more volatile component will go here. Sorry, thermometer reading of the first will be the most and last will be the least. Because when you heat it, more volatile component will run and start getting here, collected here. More volatile will go here subsequently. So this is more volatile component will completely come into this and less volatile will ultimately completely convert into this. So this distillation process is the real process where you are going to separate it naturally. And so it looks like this. So these are the two phase diagrams. That belongs to the ideal situation. Then it becomes very interesting for the non-ideal situation. Because they're in a non-ideal situation, there is a minima or maxima. But I think JEE will stick to only the ideal cases, fractional distillation kind of things. Keep it in mind. The question belongs to this. Already last class, we have given you some ideas about this one. Next question was, water is added to 1 liter of buffer solution. I think this is easy. If you have done that, this is very easy. Have you got the answer? Water is added to 1 liter of buffer solution containing 1 mole each of HA and NA to make the pH of solution equal to 6. What is the final volume of the solution? Have you done this?
Didn't try.
You haven't tried. You also try this question also like this. So once again, there is a HA dissociating into A negative plus H plus. And that is a buffer solution. 1 mole each of HA and NA was taken. So that was initially 1 and that was also initially 1. Suppose I have added V liters of water into this one. V liters of water is added. We'll write here minus X, write here plus X. We'll write here plus X. But then there must be something which is coming from water as well, because make the pH of solution equal to 6. This pH is equals to 6. That means this X is equals to 6. X plus A I will write rather. X plus A. You know why? Because there must be something coming from the water. Now this X plus A must be equal to what? 10 to the power minus 6. So from this we can get A is equals to 10 to the power minus how much?
8.
8. So once we get this 8, we get exact value of X. X is equals to 10 to the power minus 6 minus 10 to the power minus 8. Take this value and put in this equation. So we know K is equals to 1 by V minus 10 to the power minus 6 minus 10 to the power minus 8. If you wish, you can ignore 10 to the power minus 8. 10 to the power minus 6 divided by 1 by V minus 10 to the power minus, sorry, here we have to add minus 10 to the power minus 6 minus 10 to the power minus 8. Solve for V. So I think that this is very easy, but that HA wala problem was slightly difficult. And that is also very easy by that formula. But the simple approach was, what simple approach was there? That I'm curious why we are not doing it like this. So I hope that you understand this problem as well. 11th question हो गया सभी का. चलिए next question देखते हैं. Question number 12. Have you done it? Should I discuss it? Anyone?
Sir, once can you please discuss?
This question number 12.
Yes.
Okay, this is two immiscible liquid. If they are two immiscible liquid, suppose this is A and this is B. So A will definitely create its vapor pressure and B will definitely create its vapor pressure. No doubt about that. So A will create what pressure? A will create the vapor pressure of this is 450. 450 will be taken by this and 360 will be developed by this. And the external pressure is also given as to what? 810. Okay, that means both are living happily. So in that situation, you know, pressure of A, P naught A upon P naught B will be simply what? Equal to NA upon NB. NA upon NB. The ratio of their moles will be equal to what? The ratio of their pressures. So if the distillate contains 500 gram of A, that means you already know how many grams of B is present in the distillate. You simply have to do this. P naught A minus P upon P naught B, which is equal to 450 upon 360 is equals to Na is equals to WA upon Ma divided by WB upon MB. Done?
Yes, sir.
Okay. So this is the, you know, what is the funda of this problem? This is the idea of what we call it, steam distillation. Or you see steam distillation kind of thing, we used to do that. So if two immiscible liquids are there, they will just create. Students have this doubt. So these are the two immiscible liquids. Suppose A is there and B is there. B is above A. So definitely B will only create pressure. A will not create pressure. You have probably this doubt. No. There are very fine pores in the B, and definitely A will sneak through that. And if you give time, it will definitely come to the equilibrium. So never think like this. Since A and B are pure and they're not mixing, A will create its pressure, B will also create its pressure. 100%. Question number 13 and 14 is routine one. How many distinct quantum states are possible to a P2 configuration? Last time I've given you the hint. See, in this case, you simply use the Pauli exclusion principle. No two electrons should have same set of all four quantum numbers. So that means in P6 configuration, in you have P3, there are three states, +1, 0, -1. And there are two spin states associated with this, +half, -half, +half, and -half, +half, and -half. Okay. So the idea is this, that you create 9, how many boxes? 1, 2, 3, 4, 5, 6 boxes. Just create 6 boxes. Now one box is +1 half, +1 -half. These are distinct quantum states. And 0 half, 0 -half. Then you have -1 half, -1 plus half. 6 boxes are there. And you have to put how many electrons in this? 2. So 2 objects have to be put in this one. How many ways you can do it? Factorial 6 divided by factorial 2, factorial 4. So that is equal to 6 into 5 divided by 2 is equals to 15 ways. So you will agree that these all 15 ways are different in some manner. And if you put in the magnetic field, their energy will be differentiated. Do you agree? So this is how you can do. Imagine if you have P3 state, then P3 you will put it 3, then that will be what? Factorial 6 upon factorial 3, factorial 3. That will be 6 into 5 into 4 divided by 6. That is equal to 20 ways. So maximum ways will be when we have P3, we have P3 situation. Similarly, in crystal field theory, you have D2 configuration. So in D2 configuration, you can also calculate how much will be there. D2 configuration, factorial 10 upon factorial 2, factorial 8. So that is equals to 10 into 9 divided by 2 is equals to 45. So these questions are very much on the cards. How many distinct quantum states are there?
Sir, their energies will be same, magnetic moment will be different.
In magnetic moment, if you put it in magnetic field, then energy will be differentiated. The degeneracy will be removed. Okay.
Okay.
When you put in the magnetic field, definitely the energy, the first this 3 p orbitals will split into the magnetic field. And then in other situations, this will also split into 2. Okay.
Yes.
Question number 15 is also a routine question, and you can easily do it. So sorry for this question. Why I'm not getting it? Still, it is haunting me. Next class, I'll tell you simply the simple method that PCl, which one? Dilution of A negative and B positive. Otherwise, I have told you the method. If pH is given and you could not solve the problem, this is shame on you. Problem is given. If pH is given and the problem is given, they are the most easy problem in the ionic equilibrium, whatever they are, and they give a lot of insight to the ionic equilibrium situation. PA not, this is vapor pressure of pure A. Because A is not going to mix with the B now. They're immiscible.
Yes, sir.
That is why they're not going to mix with B. So A will create its vapor pressure at any cost, and B will also create its vapor pressure at any cost. So I would say in this, the most difficult problem was this one, ionic equilibrium problem. And in this way, I had discussed the theory of this problem. Let us move ahead to last class. Ved Prakash has asked me, sir, what is inversion temperature? So I will quickly talk about the inversion temperature, but be ready for this. This is highly unlikely to be asked in JEE. This is very late hours. So inversion temperature, but you have a feeling of this thing that you know. If you don't know, then you have a feeling that I don't know, I must be missing a big point. So I'm going to discuss it in stepwise manner. Okay. So I created a note out of it. See it how I'm going to explain and what is there in ITJ which can be asked. So I've taken like this few questions I've included here, which is related to the first law of thermodynamics and also second law of thermodynamics. So what is isoenthalpic process? Please, Ved Prakash, open your camera, then I can only teach because you asked me. Somebody needs to be there. Have you studied isoenthalpic process?
No, sir.
No. So see, isoenthalpic process is very much in your syllabus. You can say a process in which enthalpy is constant. Give me affirmation if you understand the process. You are pushing this piston from left-hand side. You're pushing this piston from this side. Piston is going inside. And there is a barrier. Across the barrier, here the pressure is P1. Here the pressure is P1. And here the pressure is P2. And the P1 is greater than P2. Can you feel it, the process? Gas will simply go from, high pressure region to low pressure region, something like this. So this is called throttled expansion. This is called throttled expansion. In thermodynamics, there is a special term. Throttled expansion means what? You are going from high pressure region to low pressure region. What do you think? Left hand side, you are doing positive work or negative work on the gas? Positive work, because that is the work of what? Compression. In left hand side, there is what? Expansion. There is a negative work. Okay. So what will be the overall work in the process? And this wall is adiabatic. This wall is adiabatic. You're not allowing any heat to come inside it. Wall is adiabatic. Okay. See what will happen. Gas allowed to move from P1 pressure to region P2 pressure region. Suppose 1 mole of a gas is taken. We have taken only 1 mole of gas. So it has 1 mole of gas is taken from P1 pressure to P2 pressure. So what will happen? 1 mole of a gas which was initially in the P1 region must have volume V1, molar volume. That molar volume is totally passed into the other side. So 1 mole of a gas from P1 to P2 pressure, from V1 volume to V2 volume has gone. So total work done is equal to minus P1, chemistry sense minus P1. Final volume is 0 for the left hand side and initial volume was V1. So 0 minus V1 minus P2 and final volume is V2 and initial volume is 0. Do you understand this? It is net work done. And that is coming out to be P1 V1 minus P2 V2. That is done. And in the process, Q was equal to 0. So if Q was equal to 0, then delta U becomes what? Delta U becomes U2 minus U1 is equals to P1 V1 minus P2 V2. Do you agree? So U2 plus P2 V2 is equals to U1 plus P1 V1, which means H2 is equals to H1. So this process is called isothalpic process. Done. So if somebody asks you what is isothalpic process, you quickly learn this is throttling process. Gas is going from high pressure region to low pressure region, and you have kept the adiabatic conditions. That is a isothalpic process. Why I talk about the isothalpic process? Because in this isothalpic process, ideal gas behave in a certain manner and real gas behave in another manner. That is the most interesting thing. So this experiment was carried out by Joule and Thomson. So when they first carried out in the ideal gas, what they found that during the process, when the gas is expanding, there is no difference in temperature. That means the second region, the gas is there. The gas was the temperature of second region and the first region was same. If the gas was the temperature of first and second region is same, P1 V1 is equals to P2 V2. So net work done is equals to what? 0. So net work done is equals to what? 0. If the gas is ideal. But if the gas is not ideal, so now temperature for ideal gas will not change because of this, and W is equals to 0. However, a real gas, if there is there, then this del T by del P, yani rate of change of temperature with pressure, is not 0 for real gas. The ratio rate change in temperature upon change in pressure under constant enthalpy condition is called mu JT. इसी को बोलते हैं mu JT, Joule-Thomson coefficient, which is related to inversion temperature. Because without understanding this, you could not understand the inversion temperature. So what is this? Rate of change of temperature with pressure. Now, if mu JT is positive, if this mu JT is positive, then if you decrease the pressure, temperature will decrease. But if mu JT is negative, you decrease the temperature, you decrease the pressure, temperature will increase. So for real gas, mu JT can be positive and can be negative. For real gas, mu JT can be positive and can be negative. Now to understand this, clearly understand this, what is the theory of this? Yeah, here I have shared the notes with you. If mu JT is negative and mu JT is, now thermodynamics have a very fantastic way, have a way of relating this coefficient with simple thermodynamic quantities. And most important quantity is this. These two quantities. They look horrible, but they're very simple. C del H by del P. What is the dimension of this? Volume. Because H is PV. H has a dimension of PV. This is V. This is having dimension of what? Volume. So volume minus T into del V by del P. That's a very, very, very common thermodynamic equation, a most famous thermodynamic equation of state. Similarly, del U by del V at constant T is equals to this. You verify this. These quantities are 0 for ideal gas. That is why del H by del P at constant T was always 0 for ideal gas. but they are non-zero for ideal gas and for real gases, especially the van der Waals gases. Somehow, if you know these two equations, you know all first law, and very, very interesting things of the first law, Another very important fact is that if you know this also in thermodynamics, that if the three variations are there, z is function of x and y, then there is a very important mathematical rule, thanks to the Euler's, that del z by del x at constant y into del x by del y at constant z into del y upon del z at constant x is equals to -1. This is a fantastic cyclic rule, which can be proved like this. And thermodynamics uses this extensively. Okay. Now here z and fx and y could be p is function of v and t. So what you can write? Del p by del t at constant v into del t by del v at constant p into del v by del p at constant t is equal to -1. So these quantities are used extensively in thermodynamics. So using these quantities, you can also understand important results which can be derived very easily from thermodynamic equation of state I'm showing you. Simply write dH is equals to du plus pdv plus vdp. Simply write this. Substitute dH, instead of dH, you substitute this. Instead of dH and du, you substitute this. It will become this. Okay. And then finally, wherever delta H by these terms are coming, you substitute these terms. You will finally get this expression. Cp minus Cv into dt is equals to this. All other things will cancel. And finally, what do you do this? At this stage, differentiate it with respect to T and keeping the P or V constant. If keeping T or V constant, you differentiate it, you get a very, very simple result like this. But this is a simple result, but a fantastic result. This gives us idea about difference between Cp and Cv for any substance, not just for the ideal gas. For any substance, for real gas, for van der Waals gas, for liquid, for solid. Here, del P by del T at constant V don't seems to be very useful quantity. But this is a very useful quantity because this is related to expansion. We already know that 1 by V, del V by del T used in physics extensively is equals to alpha. That's a very important thing. This is isothermal expansivity coefficient. Similarly, del V by del P at constant T into 1 by V is also very important. This is called K with a negative sign. This is called isothermal compressibility. How much substance you can compress, rate of change of volume with pressure. These two are very important things, but del P by del T at constant V is not very important. So quickly we can change this. We can change this del P by del V by cyclic rule. We can change like this. And if we can change like this, we can substitute in this equation and we get a very interesting equation. Cp minus Cv is equals to T into alpha V Kv. You get this expression. Now this expression, if you know, you also know how the water's heat capacity relates. You might have heard that water's heat capacity Cp is equals to Cv, where at 4 degrees centigrade, you can justify that. Because in case of water, 1 by V, del V by del T at constant P, alpha. This alpha varies and at 4 degrees centigrade, the value of this becomes 0. You might have heard it. The density of water is maximum at 4 degrees centigrade. So that means at that point, del V by del T is changing and at that point, alpha becomes 0. So that is the only point where Cp is equals to Cv. So this is such an interesting thing. We can easily get into this one if you are exploring thermodynamics into this one. Okay. So alpha is mostly positive. Alpha is mostly positive, but only in case of water, it can be negative. But still Cp will always be greater than Cv. If somebody asks you, will Cp will always be greater than Cv? Yes. Because alpha may be negative, but alpha square will always be what? Positive. V is also positive. K is also positive. So definitely Cp will always be greater than Cv. So these things are also covered. I've written all these points. Quickly go through it and you will get it. Now coming on to this mu Jt part. Mu Jt becomes what? Del T by del P at constant H. Once again, we will apply the same rule. T, P, and H, del T by del P at constant H into del P by del H at constant T into del H by del T at constant P must be equal to -1. What useful quantity you can see here? You can see here one useful quantity is this, because it is related to Cp, del H by del T at constant P. We have removed this Cp from here. Rest other two quantities are not very useful, del T by del P and del P by del H. Del P by del H is already, mu Jt. Sorry, del P by del H is not very useful, but del T by del P at constant H is very useful. So these two quantities are very useful. Middle quantity we have to manipulate. So I have written it like this: mu Jt del P by del H constant T is equals to 1 by Cp. So negative of mu of Cp into this one comes down to be this: del H by del P at constant T. Now we know del H by del P at constant T. Once again, the same thing. It is V minus T del V by del T at constant P. Now this V minus T del V by del T for van der Waals gas we have to find. If you want to understand the inversion temperature, this is slightly difficult for the students, so I have done it. Slightly difficult for the students, I have done it. Okay, van der Waals gas equation is there. This is slightly difficult, don't try. So I have done it. Okay, you see what final expression you are getting. After doing all this thing, you see what final expression we are getting. We are getting this final expression. And in this final expression, you see the denominator is always going to be positive. So I have presented in such a manner, you see, denominator is always going to be positive. Think about the numerator. The numerator is containing RT upon V minus B whole square into B minus 2A upon V square. Slight assumption is needed that V minus B is approximately equal to V. This slight approximation is needed. If you take this approximation, then you can see that if RT by B term is more than 2A by V square, then this term is going to be positive. Then mu Jt is going to be negative. Okay. So finally, you see that if T is greater than 2A by RB, if T is greater than 2A by RB, can you understand? V minus B term bahar nikal lo. 1 by V bahar nikal lo. Now it is RTB minus 2A. RTB minus 2A term is left here. So if RTB is more than 2A, then that means temperature is more than inversion temperature. In that situation, mu Jt will be negative. And if mu Jt will be negative, opposite will happen. And if it is less, then it is positive. And when it is positive, gas will cool after expansion. So this is the mathematical description of it. And this is also an approximate, funda. Don't take it very seriously, because you have seen that V minus B you have ignored to get to this result. Although this is very valid, because at inversion point, the volumes are very large, pressure is not very high. So of course, B is very small, quite valid, only valid for van der Waals gas. And keep it in mind that van der Waals equation is not very successful. So it's just an estimate. Better estimate of inversion temperatures comes from other equation of state. Got it? So quickly go through it. Don't research it. Just keep it in mind. This is another temperature. This is inversion temperature. Don't try to do this because it will consume a lot of time. Okay. And if you are not doing it properly, then this quantity, simple liquid quantity V minus T del V by del P at constant T, you'll get different expressions, and that expressions will become very difficult. Okay. So that is inversion temperature, and I've covered all the topics here. Go through it. Thank you for this one. Anything else? Okay. So few questions have been given to me, like this one. A solution of 0.1 m Cl negative and 10 to the power minus 4 m CrO4 2 negative. Solid AgNO3 is gradually added to the solution. What will be the concentration of Cl negative ion when Ag2CrO4 negative begin to precipitate? KSP of this is given. So what is the idea of the problem is, see, CrO4 2 negative KSP is given 10 to the power minus 12. So that means CrO4 2 negative concentration into Ag plus concentration whole square must be equal to 10 to the power minus 12. And the second equation is Cl negative concentration into Ag plus concentration must be equal to 10 to the power minus 10. You see, Cl minus is equals to 0.1 and this is 10 to the power minus 4. If it is 10 to the power minus 4, then if you put some Ag plus concentration into this, and first we have to find out which is going to be precipitated first. For the precipitation of this, you need what? Ag plus is equals to 10 to the power minus 10 divided by 0.1 is equals to 10 to the power minus 9. Upon concentration of this, AgCl will precipitate. For this one, you need what? Ag plus concentration is equals to what? 10 to the power minus 8, 10 to the power minus 4. So, in question number 27, it is clear that Ag plus Cl negative will be precipitated first. And if Cl negative start getting precipitated out, the question becomes question of selective precipitation. Okay. The question is now of selective precipitation. So I hope you understand the problem now. The question is of selective precipitation. What to do now? What will be the concentration of Cl negative when Ag2CrO4 begin to precipitate? Of course, lot of Cl negative will removed, then only Ag2CrO4 will begin to precipitate. When it started to precipitate, what will be the Ag plus concentration? Ag plus concentration whole square will be Asp upon 10 to the power minus 4. So that is equal to 10 to the power minus 12 divided by 10 to the power minus 4, 10 to the power minus 8. So definitely Ag plus will start precipitating when its concentration is 10 to the power minus 4m. You understand? जिन्होंने भी पूछा है. So Ag plus if 10 to the power minus 4 is there, what will be Cl minus concentration here? Cl minus into this Ag plus must be equal to what? Asp. So Cl minus here will be equal to Asp is 10 to the power minus 10 and Ag plus is 10 to the power minus 4. So that is coming out to be 10 to the power minus 6m. So when Cl negative is 10 to the power minus 6m, then it will start getting precipitated. So what is the answer? A is the answer. So that is a very easy question. And frankly speaking, we are discussing much a difficult question here, but you can ask. Okay, no problem. Nevertheless, you can ask. You can ask these questions personally to me. You can call me and I'll give you the hints to solving these problems if you have any difficulty in this one. Okay. See this question. What kind of question is this? AgNO3 is mixed with NH3 solution. Then what is the concentration of AgNO3 in the solution? So first of all, this is C AgNO3, Ag plus, you are mixing with NH3. What you need to do, this is C 500 ml 2m. If you mix these solution, it will become 0.2 m and this will become 1 m. And they should react to form what? Ag NH3 whole twice plus. Idea of this problem is completely react them. Why you completely react them? Because equilibrium constant of the both reaction is equals to very high, 10 to the power 7. Simply react them completely. Leave here 0, leave here 0.6, okay, and make it, sorry, 0.2 there, yeah, all right, 6 and make it 0.2. Understood? Don't ask any. Completely react them and form this AgNH3 twice plus. Now you see problem from this perspective that you have AgNH3 twice plus and it want to dissociate into the solution into Ag plus NH3 In fact, it wants to dissociate like this: Ag NH3 plus NH3. First one will come out, and then Ag NH3 plus will dissociate into Ag plus NH3. This equilibrium constant is opposite of this. That means opposite of this is 1 upon Kf2, and this is 1 upon Kf1. So how you will proceed to solve this problem? This is 0.2. Equilibrium constant of this is very small. Already NH3 is present how much? 0.6. What do you think, is this reaction is going to proceed much further? X, and the X is going to be added up here. In all probability, this X is going to be very, very small. Now from this X minus Y, you are going to get this Y, and NH3 is how much? X plus 0.6 plus Y. Take the assumption that X and Y are very small. X and Y very, very much less than 0.6. Take this assumption, and your intuition is telling you that that should be the situation. So you know practically the NH3 concentration, you have to take 6.6, and you have to get the all other concentrations. Can you do it now? So
Yes, sir.
the 1 upon Kf2 is equal to X into 0.6 divided by 0.2. Get the value of X. After getting the value of X, you will realize that indeed your approximations are absolutely all right. Can you do it now? Okay.
Yes, sir. So I got the remaining two, so we tried again.
Yeah. And this is a peculiar problem, 12th problem, which you have mentioned here. FeOH whole twice is a diacidic base. First time you see that somebody has given the stepwise dissociation of FeOH whole twice. Okay. So this is completely dissociated. What we have to do once again, Kb1 is given, Kb2 is given. We have to write FeOH whole twice, dissociating into FeOH plus OH negative. And already Fe is there in the solution. And the second step is FeOH plus is dissociating into Fe2 plus OH negative. First equilibrium constant is 10 to the power minus 4. So there is some flaw in this problem. It is not given that FeOH whole twice, if it is iron, it is soluble or insoluble. From where you get this problem? Anyone? There is a flaw in this problem because it is not written that we have to assume that this is solid. Chalo assume kar lete hain. If it is solid, then it is X and this is X, and this is X minus Y, and this is Y, and this is Y. So total OH negative is equals to X plus Y. And in all possibility, Y will be very, very much less. Y will be very, very much less than X. So the problem will be solved like this. This problem seems to be some faulty problem, but nevertheless, to get the answer, I can tell you the approach. It is not written, but I have to take it solid. FeOH plus OH negative, FeOH plus Fe2 plus OH negative. This is solid. X minus Y plus X plus Y, X minus Y. Assume Y is very, very much less than X. This is 10 to the power minus 4, 2.5 into 10 to the power minus 6. So your equation look like this. 10 to the power minus 4 is equals to X into x. So x is equals to 10 to the power minus 2. So if x is 10 to the power minus 2, then y is equals to what? Y into x divided by x is equals to 2.5 into 10 to the power minus 6. Our assumptions are simplified. So what is the answer? What is the concentration of? What rubbish is this? Fe which hold twice? Okay, let me take another chance. So this means that the examiner is not assuming this to be like this, because this Fe which hold twice is some hypothetical substance, it seems to me, because concentration is asked and given. Then I am left with no other option. Fe2 plus is there, reacting with H2O, forming FeOH plus H plus, and FeOH plus H2O changing into FeOH twice plus H plus. Fe2 plus take 0.1 minus x and x, and this is x minus y, y and y plus x plus y, x minus y. The equilibrium constant of this is equal to Fe2 plus. Hydrolysis of Fe2 plus is taking place. So FeOH is breaking into this Kb2. This is Kw upon Kb2. And this is Kw upon Kb1. The equilibrium constant of this is equals to 10 to the power minus 14 divided by 2.5 into 10 to the power minus 6, coming out to be 1 by 2.5, 1 by 2.5 into 10 to the power minus 8. And equilibrium constant of second is 10 to the power minus 10. So first equilibrium is very small. X minus y can be taken as x is very, very small, and y is going to be smaller than x. So by these assumptions, we can get x is very, very much less than 0.1 and y is very, very much less than 1. X. Take these two approximation. Okay. And don't think that this is iron, because that it is going to destroy our concepts. FeOH whole twice don't exist. Okay. Just think about it as a hypothetical problem. Okay. And now your answer is 1 upon 2.5 into 10 to the power minus 8 is equal to x square upon 0.1. So that means 1 upon 2.5 into 10 to the power minus 9 is equals to x square multiplied by 10 divided by 10. So 10 upon 2.5, that means 4 into 10 to the power minus 10 is equal to x square. X is equals to 2 into 10 to the power minus 5. X. So you have to get the value y. So y is equals to what? 10 to the power minus 10. The second equilibrium is equal to y into x divided by x. I wasted a lot of time. Simply answer is 10 to the power minus 10. Okay. Done. So question number 12 is a hypothetical question. Take it like this. And the third one is, I think that quite easy. You can do it on your own. S3 is a weak triprotect.
Yes, sir, I got it.
Got it? Yeah. Okay, bacho. It's well over 20 minutes. So I will put the homework for the agenda for the next class on the group. That is it for today's class. Thank you.